Hello viewers, today I am going to discuss about structural active relationship of barbiturates as well as synthesis of barbitols. This topic comes under sedative and hypnotics. So first we see that synthesis of barbitols. It's a very simple synthesis. Urea undergoes treated with diethyl malonic ester in presence of sodium ethoxide. So with elimination of ethanol to form barbitol. Next is structural active relationship of barbiturates. So here I have drawn basic structure of barbiturates. So here I have modified three groups. One is 5,5 disubstitution, substitution or modification at nitrogen position, and substitution or modification of oxygen position. First here 5,5 disubstitution. So here 5,5 disubstitution is essential for activity. So if in fifth position 2 substitution is must. So it produce for activity. The next one is 5 monosubstituted barbiturates are inactive molecules. If it is one substitution present at the fifth position, the compounds are inactive molecules. Branching or unsaturation and aromatic substitution at fifth position increase lipophilicity and the activity will be shown. So here any branching of fifth position or unsaturation or aromatic substitution present at fifth position, it may be produce lipophilic character. So and also produce activity. So halogenation of 5 alkyl substitution increase the potency. In fifth position, any alkyl substitution present along with the halogen, it will be increase the potency. Next one is introduction of polar groups like OH group, NH2 group, COOH group or sulfonic acid group in the fifth 5 alkyl substitution, decrease the potency. So next one is if it is a shorter chain present at the fifth position, it will produce longer duration of action. If it is long chains are present at fifth position, it will produce short duration of action. Next one is substitution on nitrogen or modification on nitrogen. First point is replacement of imide hydrogen with alkyl group. It will produce in quicker onset of action as well as shorter duration of action. So first position and third position are modification here. Replacement of any imide hydrogen alkyl group may be produce quicker onset of action as well as shorter duration of action. Second point is increase in length of alkyl chain imparts conversion properties to barbiturates. If it is number of alkyl group present at third position or first position, it will produce conversion effect. Third one is attachment of alkyl groups to both nitrogens produce inactive compounds. If any substitution present fifth and third position, it will produce inactive compounds. Next one is modification of oxygen. So here second position, fourth position and sixth position, any modification here. Substitution of C2 oxygen by sulphur increase the lipophilicity and hence the activity. The second position, if it is substituted in presence of O group, you have to substitute sulphur group. It will increase the lipophilicity and produce activity. For example, thiobentol is ultra-active acting thiobarbiturates. Next one is for substitution of more oxygen atoms with sulphur, like second and fourth position or second and fourth and sixth trithio decrease the activity. If it is only second carbon in place of O, sulfur produce will increase the lipophilicity. If it is second position, fourth position, sixth position, if it is modification with sulfur, it will decrease the activity. So thank you to all.